This video goes through the solution to Effective Maths 2, page 179, question 5. And it asks us to write 1.2 recurring, 7 recurring in the form p over q, where p and q are elements of n. So the first thing that I need to do is take my 1.2 recurring, 7 recurring, and just write it out a little bit longer, with more decimal places, with the view to writing it as the sum of terms. So we can see that we're able to split up our 1.272727 dot dot dot, and make sure to put in the dot 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 to indicate that you continue, into the initial 1 and then the recurring portion of the decimals. So 0.27, 0.0027 and so on. I'm going to hold the 1 for a moment because the 1 is clearly not part of the pattern that is created by the rest of the series. And I'm going to treat the 0.27 and the subsequent terms as a series in their own right. And as the dot 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 indicates that I'm going to continue on indefinitely, I'm going to consider this to be an infinite series, and I want to find its finite sum. So I want to find the sum to infinity, and so I'm using the formula a over 1 minus r. I'll need to note the a and the r. The a will be the first term of this series. In this case, that's 0.27. I can calculate r by dividing any term in the series by the previous term, and in this case, that works out as 0.01. I can now go ahead to calculate s to infinity. So I've filled my formula in, and when I evaluate it, it comes out as 3 over 11. But I'm not quite finished yet, because this only deals with the portion from 0.27 onwards. I mustn't forget about that original 1 also. So now what I'll do is I'll take that 1 and I'll add the 3 over 11 to it. Obviously this gives me 1 3/11. I've been asked at the beginning of the question to write my answer in the form p over q, so I want to write this as an improper fraction. And 14 over 11 is my final solution. So 1.2 recurring, 7 recurring in fraction form is 14 over 11.